Hi grade 11s, welcome back to another one of our video lessons. So today we're going to continue on page 180 with unit 2, which is models. And we're going to be packaging containers within containers. So generally every item bought today in a store arrived in the store in some form of packaging. This unit will focus on cost-effective packaging. Alright, so in this unit we're basically going to look at the least amount of packaging material needed in order to package some certain amount of cans or boxes or whatever it is that we are packaging. Alright, cool guys. So before we can get into this, we need to recap our surface areas and area and volume formulas. So I'm going to run through the table on page 180 from the top. So circumference of the circle, remember, what is the circumference? If we have a circle with center, the circumference is the outside perimeter of the circle, right? And the formula for that was circumference C equals 2 pi r, okay? Or it equals to 2 pi, or rather just pi d, okay? Because 2r is the same thing as the diameter, okay? So circumference 2 pi r or pi d. All right. Area of a rectangle is length times width. That's pretty straightforward. Area of a triangle is a half times base times perpendicular height. Okay. Remember that thing about the perpendicular height. It's always base and a perpendicular height. Your triangle can even have a longer base and meet in the middle like that. As long as you have that perpendicular height times by the whole base, you'll be fine. All right, area of a circle is pi r squared. So if we want to now find surface area, what we're going to do is say surface area of rectangle box is, well, if we have a rectangle box, okay, remember it's got 6 sides unless it has an open top, okay? So it's got these 2 side panels, these 2 side panels, and top and bottom, okay? So when you're working out with surface areas of boxes, you've got to take all of those into account. And also pay attention to the question, because they'll say this box has a bottom but no lid, or it has a bottom and a lid, okay? So now it's either 6 surfaces or 5 surfaces. All right, but basically the surface areas is just taking any of the 2 dimensions, multiplying them together would give you the 3 surfaces, and we just times it by 2 because there's always another side on the other side of the box. All right, so surface area of a cylinder with closed lid and base. Okay, so here we have a cylinder. Okay, it's got a closed lid and base. I'm going to draw this in a dotted line to show you that it's in the back. All right, so how do we find out the surface area of this? Well, we need the radius of the circle here, r, and we also need this height of the cylinder, h. Okay, so the surface area is the 2 circle bits on the top, which is pi r squared times 2. And then we need the surface area of the side, the round bit of the cylinder, okay? So how do we do that? Well, we need to work out the circumference of this piece. So imagine we take this can and we roll it out on the table. So where this can rolls, that's the surface area that we need. So the distance of that will be the circumference of the circle. So we can measure that by saying 2 pi r or pi d multiplied by the height. Okay, so if we roll this can out, we should get a flat piece like this. So this distance will be c, which is the circumference, and this will be the height. Okay. Right, guys, so that is the surface area of our cylinder. Now, if we're talking about volume, volume of the rectangular box is your length times height times width, okay? Volume of a cylinder, area of base lid times height. Okay, so if we want the volume, we're going to just say the area of the circle here, so pi r squared, multiplied by the height, which would give us the volume. Okay, guys, so these are the formulas that you must know in order to do this kind of calculation, but you would have known it from the previous section when we did perimeter, area, and volume. Alright guys, let's look at page 180, worked example. So number one, it says 6 cylindrical tins, each with a diameter of 7.5 centimeters and height of 11.2 centimeters are to be packed into a rectangular cardboard box. If the tins are packed as indicated in the figure and there are 2 layers of tins in the box, then find the following. Okay, A, calculate dimensions of this box. Okay, so the dimensions of the box is length, width, and height. So we need to make a box so that we're not wasting material. We don't want to make it obviously too big, but we can't make it too small that it doesn't fit the cans. We need to make it just right so the cans go in and there's no free space anywhere so that we're not wasting the packaging material. Because if we have to make 1,000 of these boxes, that little wastage in one box will multiply by 1,000 and it will translate into real costs. Alright guys, so what we need to understand is that how these cans are packaged and what are the dimensions. So they have a 3 by 2 and there's 2 layers. So we have 1, 2, 3, 4, 5, 6 cans like that. Okay, so we have 6 cans lined up like that, and remember they told that there's 2 layers of them, so I don't have space to draw. What I'm going to do is I'm just going to divide these into 2 like that, and now it looks like that there's 2 layers of cans, 1, 2, 1, 2, 1, 2. Right, so there are 12 cans in total. Right, now let's figure out what are the dimensions. Okay, so the information that they tell us is that 6 cylindrical tins, each with diameter of 7.5 centimeters and height of 11.2. Okay, so this height of one can is 11.2 centimeters and the diameter of the can is 7.5 centimeters. Now remember guys, diameter is not radius, so the diameter is the entire distance, and that is 7.5. Excuse me. Right, so the diameter is 7.5 centimeters. The height of each can is 11.2 centimeters. So, well, let's figure out the length of this box. Well, we got 7.5 there, 7.5 there, 7.5 there. 7.5 times 3 is going to give us 21, 22.5. Okay, so this is going to be, so the length of our box needs to be just a bit more than 22.5, but we'll leave it at 22.5 because that will mean that they'll fit perfectly into that distance. Okay. Right, what about the width of the box? The width of the box is going to be, remember guys, when we're dealing with round cans, the radius is always the same. So the greatest distance that the circle can take up lengthwise is the diameter of that circle, right? So the greatest distance we need here is that plus that, so which is 2 diameters. So 7.5 times 2 is going to give me 15 centimeters. All right, so this is going to be our length, this is going to be our width. Now we need to work out the height. The height is 2 tins on top of each other, so it's 11.2 times 2 is going to be 22.4. So our height equals 22.4. All right. Cool, guys. So those are our dimensions of this box. Let's see what they say in the answer. 22.5 times 15 times 22.4. Exactly. All right. I left out centimeters there. All right, B, calculate the total surface area of the cardboard used to make the box. Okay, so if we look at that box, what I notice is that it doesn't have a lid, okay? And they didn't tell us anything about a lid. So let's see. Well, actually in the solution, they used the 6 surfaces. So they assume that there is a lid. But if you guys assume that there is no lid from the picture, I would be fine with that as well, because they said nothing about a lid and I can't see the lid there. At least they could have drawn it half open. Then it would mean that, oh, okay, it closes and we need to include that. But either way, let's follow their solution. So, okay, we know what this looks like. I'm going to erase these cans. We can write 11.2 times 2 equals 22.4 centimeters equals height. Okay, so I've just written out those dimensions. Right, so surface area equals. Remember, we have 6 sides or 6 faces, and 3 of them are different. So we've got 3 different dimensions. So if we multiply any 2, then we're going to get those sides. Okay, so let me draw a little box over here so we can look at it as we do this. So let's work out this face over here first. Okay, that is length times height. Okay, so, and remember we have 2 of those surfaces, so it's 2 times length times height. Length is 22.5 times height is 22.4. Cool. Plus, right, we've done that one. Let's now do this surface here. That is the width and height. So again, 2 surfaces, 2 times width is 15 times height 22.4 plus, okay, so here let's assume there is a lid, so this surface over here times 2 would be length times width, so 2 times into length 22.5 times width, which is 15, and that would give us an answer. They tell us that is 2310 centimeters. Now remember, we're dealing with area or surface area, which means that it's centimeters squared. Okay. C, convert your answer in B to square meters. All right, so guys, this is a common question. I'm always going to ask you to convert from one thing to another. So we need to first go back and figure out, I mean, unless you learned all these formulas and you can remember them from scratch, we can figure this out by just imagining, well, 1 meter equals to what? 100 centimeters. Okay. If we have 1 meter squared, that is 100 times 100, because 1 meter is 100, 1 meter squared is 100 times 100. So it's 100 and another 2 zeros, centimeters squared. So 1 meter squared is 10,000 centimeters squared. So how are we going to convert this into meters squared? Well, we're going to divide by 10,000. So 2,310 divided by 10,000 equals to, well, cross out 1 0. 231, we're dividing by 1,000 by 3 zeros here. So we're going to move the decimal 3 places back. So it's going to be 0.231 meters squared. Okay. And that kind of makes sense because we know 10,000 centimeters squared is a whole meter. We have only 2.3, so it's almost a quarter. So we shouldn't get more than 0.25 meters squared, and we don't. Our answer is 0.231. Okay. Right, D. In one day, a factory makes 1,250,000 of these cardboard boxes. How many square meters of cardboard do they use in a day? All right, well, if we have this much in one cardboard box, in 1,250,000 we have, well, multiply that. So we can say that 0.231 times 1,250,000 cardboard boxes equals. Okay, you can put that onto a calculator, and the answer you should get is 288,750. Okay, 288,750 what? Okay, remember, what are we trying to work out? How much cardboard they use in a day, how much square meters of cardboard. Okay, so this is meters squared. Okay. Right, guys, that's the worked example on these packaging arrangements. So what I want you to do is do exercise 5. That's going to look at almost exactly the same worked example. We're just packaging cans in a different arrangement. So you guys have to figure that out. Work through exercise 1, question 1 and 2. Then the practical exercise we're not going to do. Okay, we're going to skip that. And we're also not going to do exercise 6. I don't think these are very important, and they usually ask in the exams, they usually ask the questions on these models and packing arrangements rather than these next few exercises. All right, guys, so what I want you to do after that is do revision on page 184. Okay, if you haven't done that already. And then we're going to get onto taxation in our next lesson, which is page 186. We're going to look at value added tax. We're going to see how shops exempt some items from tax, such as it's usually fruit and veg and milk and bread and necessities that are exempt, so people don't pay tax on that. We're going to look at unemployment insurance fund, or UIF, and how that works. And then we're going to get into probability, which is our topic 10. Okay, cool, guys. I hope you enjoyed this. Please do exercise 5 and the revision of this section. And I'll see you in our next lesson and hopefully next week at school. Cheers, guys.